A little bit about me. I'm an Android developer. I've been for about 5 years now. I work at Carify. We create an online platform to treat mental health patients, and I create the Android app for that. Besides that, I help my wife with her food blog. She has a blog about food and recipes and restaurants, and I do the technical part of that. And for my work, we had to look at cross-platform solutions, and being an app developer, my wife is always like, oh, why don't I have an app yet? So I also thought like, well, maybe I should look into creating a cross-platform app for the blog. So I started to research which frameworks are out there. And for my work, we chose to go with React Native. But being a hobby project and being able to do new things, I found out that Flutter was being developed, which is a new framework from Google. If you go to the main site of Flutter, it says, Flutter is a new mobile app SDK to help developers and designers build modern mobile apps for iOS and Android. Well, that sounds kind of markety kind of way, and we probably heard that before with other cross-platform development tools. And most of the time, they don't really live up to the expectation. So I thought, well, it's Google, so there are smart people there, so they probably do something right. And I started reading about it and trying different example apps. And I found it really interesting, and I thought, well, I'll do a talk about that. A little bit about Flutter. Flutter is written in Dart. I don't know if anybody knows the language. It's a language created by Google. It's an open source language. It's been around for about 6 years. They created it to be an alternative for JavaScript, because if you want to use JavaScript for big applications, you hit certain limitations. And they decided, oh, well, let's create a new language for that and fix those problems. And of course, it's not really being used by a lot of people, but it is an easy language to pick up. If you're a JavaScript developer or a Java or C# or Objective-C or probably any kind of developer, it's really easy to pick up because they looked at different languages and picked parts of those languages and combined them. So it's really familiar to most developers and easy to start using. In Google, they are using it really a lot. It's, I think, the second largest used language in Google. They recently redid Google AdWords with Dart, redid the whole platform. So it is something that they are using, and it's not like, well, if you start using it and next year it's going away. I think they are aiming to make it better and keeping it around a long time. And Flutter is a framework that is written in Dart. It's a whole framework. You have, if you compare them to other frameworks and the native platform, you have the normal MVVC, MVP, MVVM patterns you would use for native development, like the Java or Kotlin SDK or the Objective-C or Swift SDK. You could do the same thing for a JavaScript cross-platform framework like Titanium, Cordova, or PhoneGap. They work kind of the same way, only the Android and the iOS SDKs are compiled to native, and the other ones are usually interpreted by a runtime in JavaScript, which has some downsides if you want to use that in apps. Then you have, of course, React Native and NativeScript, which are new ways of doing cross-platform because you are using native parts of the platform. The only thing that's different is that you have to supply a JavaScript runtime with your app, and you have to cross the bridge from JavaScript to native code and back, which can be a bit performance downer if you don't really look into that and fix those issues. And then you have the other part, which is Flutter. It's based also kind of way on React Native and React. It uses the reactive view philosophy pattern that they designed at Facebook. And they just said, well, it's actually pretty good to use. It's a new modern way of creating views. Let's also use that. And instead of using JavaScript or compiling to JavaScript, they are compiling that code down to machine code. So it's the same way if you would write C++ for Android or iOS. That also gets compiled down to CPU code. Flutter is doing the same. So you write something in Dart, and that gets compiled down to actual native code. Actually, Facebook is also doing something quite similar. They created ReasonML, which is, I think, probably the next step in the React and the React Native framework, which also takes one language, JavaScript, and compiles that down to machine code to be run on actual devices. So both companies are going after kind of the same approach. Of course, different languages, different people working on it. So it is interesting that two big companies are doing kind of the same thing with it. So I think it can become, in maybe a year's time or in the future, it can become a lot larger than it is now. If we look at the framework, Flutter has been designed from the ground up. You have a C++ engine, which takes part from Chrome, like Skia and the text rendering engine, to render stuff to the screen. And they are using a Dart VM, which is stripped down a bit to gain the maximum performance they can get. And on top of that, they created a whole framework to interact with that engine and draw stuff on the screen. So at the lowest part, you have the Dart UI, which is basically just a canvas, and you can, say, draw something in this position, square, text, or something like that, which, of course, if you're developing apps or developing software, is not really a good developer experience. So they created a whole another layer on top of that and a few layers on top of that for developers to really create apps with it. So you have the rendering part, which takes the widgets and creates the render elements, and it passes that along downside to the Dart UI to be rendered on screen. And on the top you have the material and the Cupertino widgets, which are few elements that are already created for you to work out of the box on both iOS and Android. And if you were going to create an app, you could use those. You could also extend those or rewrite them yourself to look different or behave differently. That's one of the big advantages of Flutter, is the whole framework is at your disposal. You can use the whole framework to do things. So if you want to do something at the Dart UI layer, you could change that. You could talk to it directly. It's not like, for instance, if you do Android, you do see the source code of a text view or a canvas, but you can't change that or change the implementation of that. You're stuck with what the platform supplies to you. And this works the other way around. The framework and the code for your app are all combined together and deployed to your device. And you might think this is probably slow because you have a whole framework, but actually it's quite fast because everything that you see here gets compiled down to native CPU code, and it uses OpenGL and the Vulkan API to do the rendering. So it uses the GPU and the CPU to do really fast drawing. The Flutter widgets, everything in Flutter is a widget. So if you want to apply some padding, for instance, normally you would add that as a property of the actual view you want to pad. But instead, they've decided to say, well, we're not going to do that. We're going to use composing instead of inheritance or properties. And you would wrap that view in a padding widget or in a center widget, and you can compose your whole view with just nesting those widgets into each other. And you can then reuse those higher level widgets that you create throughout your app or throughout different apps. Besides that, if you would compare Flutter, for instance, with React Native, React Native doesn't really give you an opinion on how to do things. They supply some basic views like a view, a text, a label, a button, and how it looks, yeah, the platform way, different on every device. So you have to create those yourself or style them yourself how you want to get them to look. And also if you look at the libraries that are around there for React Native, people usually either make a good iOS representation for it or a good Android representation. And finding both parts of the equation is really hard. And for Flutter, they decided, okay, we have material design, so we're going to implement that fully. So Flutter is also, I think, the only framework now that has the full material design specification actually implemented from the start. So if you're an Android developer, for instance, and you would want to use the account chip to make a contacts app, you would assume that would be provided to you by Google. But actually, they don't. They supply you with a text view and an image view, so you have to create it yourself or look at external libraries to get those, but they aren't supplied to you by the framework. And at Flutter, they said, okay, we're going to have an opinion on how we're going to do things, so it is easy to start with. If you follow that, you can create normal apps that work great. But if you want to do it differently, if you want to create your own implementations, your own style, you're free to do so. But you have a starting point to start at instead of having to figure that out directly. The way it works is you create a widget. They have two kinds of widgets, a stateless widget and a stateful widget. The first one is shown here. If you create some static text or maybe load an image from your assets that doesn't change during the lifetime or the compilation time of your app, you can create a stateless widget. There's no interaction with it, it just draws simply what you specify every time. And you have the counterpart of that is the stateful widget. You can create a stateful widget which has a state object which tells you how the widget should be created. And you can call initState to load the first state and then setState if the state needs to be changed. And then in the framework we'll call the build method, and depending on what the state is, it will draw either a text view loaded data or is still loading. Normally you would maybe create custom widgets that are called instead of just nesting them endlessly deep. But this is just an example. Next slide. Well, how do you set it up? Currently, they're still developing Flutter, so they don't really have an installer or something like that. You just go to the repository, clone it, and then add the binary to your path, and then call Flutter Doctor, which is a command line tool to help you install all the things needed to do app development. If you have, for instance, IntelliJ installed, it will say, oh, you need to download this plugin for Flutter and this plugin for Dart. If you want to do iOS development, it says, oh, you need to install Xcode, download all the CocoaPod to do dependency management. And every time also Flutter updates, you can call Flutter Doctor to see if you need to change things in your system to get it working. Usually if it updates, you don't have to change anything and it just keeps working, which is a nice part if you compare it to React Native, which a lot of times if you update React Native, probably going to break something in your app, which you have to migrate to the new way they're doing it. Well, I'll show you a little demo of an app I created, or I'm working on. Let's see. Mirror screen. I should have prepared this. Okay. So the first time you build the app or compile it and to install it, it takes some time to do that. One of the features of Flutter is that after the first time you do that, installing is really fast. The compilation takes like less than a second, and it gets also synced within half a second. Yeah, it's basically just a simple app downloading the WordPress API, showing a list of blog posts, and if you click one, it goes to the actual contents of the post. And it was really easy to create something like this. Usually on different platforms, you might have to optimize your list for quick scrolling or to get the performance right. But this, out of the box, works pretty smoothly. And if you want to change something around, blue. It took 700 milliseconds to load and compile and load the change. One of the big advantages is this actually works if you're in, you've used your app and you clicked a few screens and you filled in a form and you created some state and it crashes there. If you do change the code and you reload it again, the state is kept. So you don't have to restart from the beginning, go to the screen, fill in the form, and pressing next. Usually you can get it, it remembers the state of the form you filled in, and you just press next and you can continue with your workflow. So for developers, it's really nice that you have really fast iteration cycles. And it's also easy to, if you want to make changes in the UI, it's really fast to do so with actual contents instead of like creating all stops for the content. Let's see, can I break something to show you? Changes are really fast. And it just remembers I was in that screen, I wanted to show this post, and just re-render it. Okay, let's continue with the slides. So, as you can see, it was really fast in rendering the views on the devices. Normally, if you have like complex layouts, you would have to tweak them and use all the performance you can get from them to really get them to scroll fast. And this works out of the box without any optimizations. So they are really doing a good job of creating fast code that you don't have to optimize. And this is actually pretty slow because in development mode, the code doesn't get compiled down to native code. It just gets run by the Dart VM and interpreted. And once you create a production app, it gets compiled down to native code. What you saw with the hot reloading and the stateful hot reloading, those things are really nice to have if you want to have fast iteration cycles. You don't want to wait for your compilation and then installing the app on the phone and then clicking through to where you were and then retrying if you fixed it. So it's easy to develop with. You could also create it. You can also use it to create prototypes with it really fast. So it has multiple applications besides creating real apps. The first time I started it, I was thinking like, well, you have to create views in code. And well, for Android, for instance, you use XML to create your layout and then call that in the code and find the views and then bind to them. And then you get a nice separation of the view and the logic. With this, I was like, no, why would I want to create views by code and by hand? But actually, it isn't that bad, and it does have some performance gains that you can do. If you look at Android, for instance, there's Anko, which is a library that you can create views in code in Kotlin, and then it's really fast in loading those views. Also, React Native and React are also creating views in code, and they are creating really small components, so you don't need to have as much logic as you would think you would need. So it is really doable, and you should just try it out. Getting used to the project structure and organizing it. My experience is Android development, so I'm used to Gradle and the whole Android project structure and having proper keywords for instance, marking something private. And if you're using Dart, you have to use the underscore, and then it is private, which you're probably used to from web development. But in web development, it isn't private. It's just something for developers that agreed upon. If you use an underscore before a field, it is a private field, so you can't use it. But the Dart compiler and syntax detector actually knows that it's private, so if you try to use it, it will give you an actual error. So it's really a bit weird in how you use the code, but it's something you get used to. Also, the project structure, you have a library folder, and you have an iOS folder, an Android folder, and basically you don't use the Android and iOS folder, you just use the library folder to create your Dart code, which automatically gets run to the Android and the iOS project. One of the things that's really one of the bigger issues, I think, is, for instance, Json parsing. If you're on Android or on iOS, you're used to having all these tools to really make Json parsing easy. And because the Dart runtime that is used in Flutter isn't the full runtime you would get on Dart web, they've removed, for instance, reflection. And a lot of Json parsing libraries use reflection to get all the field names. And so all the libraries that are out there for Dart that use reflection, you can't use in Flutter. There are some other libraries that do code generation, so you have to set up the whole code generation. When you change the code, you have the monitor running, so it generates new code for you, which is an additional step to have. And it might not be the best solution, but the other solution is doing everything by hand, which is also very tedious. They do have a nice syntax where a JSON gets converted to a map, so it's really easy to use, but it's not typed then, so it's all strings and ints. So if you do that by hand, it's really tedious and error-prone to do that. Also, the Flutter framework currently is in alpha stages. It's being developed by Google and also a lot of community contributors. It is still alpha, but it is actually pretty good and stable to use the parts that they already created. Those are working stable. But there are features that are missing that you would have normally on the native platform. For instance, like background threading and services. So you can start a background service and let that run when your app is closed. Because they are focusing more on the view part of application development, the whole background service feature is not yet there. They are working on it and looking how to implement that in a platform agnostic way, so you have nice abstractions upon the iOS and the Android platform, but they are not there yet. So if you decide, hey, this might be something I want to create an app in, you would have to look at hey, which features would I need to have a successful app, and maybe some of those features are not there yet, but they are working on it. For instance, video playback is being worked on right now, because the Flutter framework actually does basically the same as a video player. They render stuff to a texture view, and the video player does the same, so they can't interchange those components. So they have to create a solution for that. But yeah, a few months ago, it wasn't really on the roadmap yet, and nowadays they have a working prototype of how it is supposed to work, and are currently making that more stable. So they are working hard on adding new features. I just read that they are trying to add a feature if you write a native library, like a C++ library, that you can use that directly in your Dart code instead of going all the way through the native Android or Java part and going to the C code there and all the way back, so you don't have that overhead. So you should, if you want to use it, just look at if you need the feature that they don't have yet. You could, if you are really interested, you could actually contribute to that. They're open to contributions, but it's something that you have to invest in. Also, another part is the framework doesn't really have an opinion on how you should architect your code. It's more view-based, so they took the reactive pattern and say, well, for the view part, we're going to use the reactive pattern, but how you're going to do the rest, that's up to you. Well, it is using reactive views, so it's a logical sense to use something like Redux. There are already some implementations for using a Redux kind of architecture in your apps, but it's up to you on how to do that. You could create something yourself, but they don't have an opinion on about how you should do that. So you can do anything you want with it, but there's not really a best standard yet for that. So, any questions? Mm-hmm. You can make full functioning apps. There are already a few fully functioning apps in production. Google is promoting Flutter with the Hamilton app, for instance. It's one of the biggest musicals in America. And I think that's downloaded on the Android store for 500,000 times. And they've really made that work correctly. I'm also in the GDG chat for the Flutter community, and I see a lot of small startups also looking into this and trying to create apps with it. Somebody created a web e-commerce app for it. So we can do network calls or yeah, everything you can do network calls. There are plugins to communicate with the native parts of the framework. So there are plugins to use SQLite, for instance, in a platform agnostic way. So it works on both iOS and Android. And doing everything you can do normally in Dart, like make network calls, store data, you can do. It's just some features from Android or iOS are not there yet. Yeah, Dart is the name of the language, and Flutter is the name of the framework. questions? Well, it seems you've won the book for the best question. So nobody wants to win the other book? You may ask. Yeah, you can ask a question. Yeah.
Does both Android and iOS applications shares the same code base in 100%?
If you don't use any native parts, it reuses 100% of the code. In the widgets, for instance, there are small if statements. If on iOS, for the scroll view, for instance, there's an if statement that does the bounce on iOS and the overflow in Android. So there are small things that you can look out for the platform, but basically they're trying to do as much code resharing as possible. Well, you get another book. Yeah, let's see, I'll start the emulator. I have to start up the emulator. One of the most interesting things you can do is, because all the widgets that the Android or the Google team already created, they have both a way of looking in iOS or on Android. You can actually change that flag. So if you want, you can have an iOS look and feel app running on Android and vice versa without actually doing a lot of work for it. I don't know if you would want something like that, but it's possible to do. It can be funny. So that's the back button. And if you go to the iOS one, for instance, it slides in from the right. And if you want to go back, there's the gesture of going back. And on Android, you don't have that. You have to use the back button. Currently, I think that is the Redux architecture. It's also based on reactive views. If you're used to React or React Native, it's heavily used there. And they are already have a lot of implementations for that. So it is quite a good fit if you would implement Redux. If there are no more questions, thank you for looking at my presentation, and I'll be around if you have more questions.